recording. So today's plan, we are going to play matching games and get a first chapter done. Based on the syllabus, next week we are going to start the second chapter. So today we need to finish the first chapter. No pressure, just some games, okay? Yeah, let's see, someone left me a message. Oh, hi, Dustin. Hello. Is there sound yet? Are you guys be able to hear me? And let me know. Yeah, I unmute myself, so you should be able to hear me now. And check your sounding setting. Okay, perfect. Thank you. You should be able to hear me. Some of your other classmates heard me. So, okay, let's go to my note. On Tuesday, we were going over the concept in section 1.1, right? Okay, so where were we? We finished the parameter and statistic. So next pair of concepts, representative sample and a biased sample. The reason we need a sample is because going through every single member in a population is time consuming and not practical in general. So we want to have a representative sample. From analyzing the representative sample, we can draw the conclusion about the population. So that's the idea. So representative sample is a good sample. Biased sample is not a good sample. So here I have two options. Let's match them. The first one is a random sample. This one is a voluntary response sample. So which one should I go to which one? When you do your homework, when you see the keywords, randomly select subjects from the population and form a sample. And that sample, that indicates the sample is a random sample. In next section, we are going to look at the definition of a random sample in more detail. So at this point, you only need to know a random sample is representative. When you do your statistic research, the sample you draw, the sample you get, you want a sample to be representative. So you want a random sample. This is a new concept, voluntary response sample. Voluntary response sample also is called a self-selected sample. Very likely, voluntary response sample will lead to a biased sample. Let me give you some examples about voluntary response sample. Let's say the radio station want to survey its audiences about opinions about a certain topic, and the radio station asks the audience to call in and collect their opinions. That is an example about a voluntary response sample. We can find another example. Let's say when you look at the magazine, in the magazine, sometimes they have the advertisement or some independent paper, right? By itself, you can take out. And on that paper, they sometimes ask you to survey your opinion and ask you to mail your opinion to them, back to them. That is also a voluntary response sample. Kelly, I think you would have to figure out on your end, because other classmates are able to hear me. I'm sorry about that.
No, thank you. Yeah, I just logged in from my laptop, so I'm got it on here, just not on my desktop. Thanks.
Oh, okay, perfect. Awesome. Yeah. And let's think about why a voluntary response sample very likely to lead to a biased sample. Why voluntary response sample is not a good sample? Anybody have any idea about that? Random sample is good, representative. That's what we want. How come a voluntary response sample is not a good sample, is a biased sample? Even it's biased sample, why all the magazines, radio stations, TV stations, companies, they are still using the method to get a sample, to collect data? Anybody have any ideas?
Voluntary samples, the people will only reply if they want to. So either they have a strong opinion, or maybe they, it gratifies their self-image or some other reason.
Awesome. That's a very good answer. Yes, people who respond normally are people who have very strong opinion. So if you apply the voluntary response sampling method, then very likely you only collect the data from a certain type of people. Those a certain type of people have very strong opinion. That's why they respond, right? And what about other type of people in the population? Then, you don't know. They probably will not want to respond. So very likely the voluntary response sample will not represent the whole population. So we'll give you a biased sample. Now, why are the radio stations, the companies, business still using this method? They have their own purpose, right? And also do a survey or do a better sampling, apply a better sampling method to get a random sample is more time consuming. It costs money, and voluntary response sample is easier. So that's the reason. All right, any question about this pair of concept, representative sample and a biased sample? Yeah, we need to know representative sample is good, biased sample is not good, and voluntary response sample very likely give you a biased result. If I ask you any questions and
are you speaking?
Yeah, I am speaking. Yes. Yes, I am speaking. Yes, I am speaking. We have issue about hearing me. I don't know what to say. I am speaking. So if I ask question, I would weigh 1, 2, 3. I count to 3. If nobody responds, I'll just keep going. Okay. Especially today, we have a lot to cover. Next pair, statistical significance and practical significance. If you have started to work on your assignment in MATLAB Math, the first question actually is about statistical significance and practical significance, right? Okay, let's take a guess. She's speaking. Okay, very good. Now take a guess. Which one goes to which one? Yeah, which one is the definition for practical significance? Which one responds to statistical significance? Yeah, this one says a result that justifies the use of a certain treatment or funding based on a common sense. A result that justifies the use, right, means is useful. A certain treatment or funding based on common sense.
Yeah, so common sense is practical significance?
Yeah, exactly. This one goes to practical significance. And this one, of course, goes to the statistical significance. Let's see the definition for statistical significance. Statistical significance refers to a result, or we say a result has statistical significance if the result is very unlikely to occur by chance. How do we measure unlikely to occur by chance? We normally use 5% or even less than 5%. If the probability of a result occurring is 5% or lower than 5%, we say the result is rare. Let me get my stylus and see if I can write on the board. I probably need a battery. Sorry about that. So I'll just narrate, just to say what I want to say. Yeah, so it's called a rare event. If the probability of a result has very, very small probability, then we say the result is rare, is a rare event. We assume a rare event does not occur in one trial. Okay, we have a rule in statistics. We assume rare event does not occur in one trial. That's the reason we feel comfortable driving, right? Yeah. So when you drive your car, what's the chance of have an accident or a very bad accident? We cannot say it's zero, right? Because you don't just control yourself. You have to. It also depends on other drivers. It's definitely not 100% safe. There's a chance you have an accident, but we assume that will not happen in one trial, right? Yeah. Also, the reason statistician and mathematician they do not go to buy the lottery is because they believe in the rule. Because in one trial you win a lottery, the chance is very, very low, and we assume that's not going to happen. So we do not want to waste the $1 or $2. And when a result happen, when a result does occur in one trial, of course that draw your attention, that deserve your attention, right? And we say that result has statistical significance. So I hope the explanation can help you to understand and remember the definition for statistical significance. We say a result has a statistical significance if it is very unlikely to occur by chance. If a result is very likely to occur by chance, then we say the result has no statistical significance. I can give you another example. I'm going to type here, okay? Yeah. Let's say you have a coin, if you have a coin, just a coin. You have a coin. And what you're gonna do is you're gonna flip the coin for how many times? 100 times. Flip a coin for 100 times. Okay, you do the experiment twice. The first time, the chance of getting a head, or the number of, the chance of getting a head is, let's say, 52 over 100. So among 100 trials, we have 52 times getting head. And the second experiment, and you toss the coin another 100 times, and you're getting head. The chance of getting head is 97 over 100. So two results. Okay, this one is result 1. And this is result 2. I want you to tell me which result has the statistical significance, which result does not have the statistical significance. Which one? Oops, sorry. Result 2. Result 2 does have or does not have. I would believe you mean does have, right? Yeah. Result 2 has this one has statistical significance, because this result is very unlikely to happen by chance, right? 100 times and 97 of the times you got a head, that's something draw your attention. Probably the coin is not fire, right? And this one, let's say the two coins are different. This one does not have a statistical significance. Very likely we get a 52 out of 100. Yeah, even it's not exactly equal to 50%. Yeah, we know you flip a coin, the chance to get a head is 50%. even not exactly equal to 50%, but it's very close. Okay, awesome. I think you understand the concept. Next, we have a correlation and causality. So when you read results from statistical researches, sometimes they study the relationship of two variables, right? Yeah. So in next chapter, we are going to learn a type of graph. It's called a scatter plot. A scatter plot would give us scatter plot will give us the relationship of two variables. Suppose we have two variables. X is the IQ score of a husband, and Y is the IQ score of the wife. Of course, the husband and the wife are a couple. Not the other people's wife. They are a couple. So we have two variables. X represents the husband's IQ score. Y represents the wife's IQ score. And then we got many couples. We invite many couples for the research, right? And we get a bunch of data, and then we can graph those data on a rectangular coordinate system, and we would be able to get a bunch of dots. We will see a trend. We probably will see this trend. Yeah, if the husband has a higher IQ score, the wife normally also has a higher IQ score. So when that happens, when the relationship of two variables demonstrate or display a certain pattern, like a linear pattern, right? Yeah, in my earlier example, probably is a linear pattern, or sometimes the pattern even could be parabola. Yeah, the relationship even could be parabola. So when that happens, when the relationship between two variables demonstrate a certain pattern, we say there is a correlation between the two variables. But people often mistake correlation with causality. In my previous example, yeah, we see a correlation between the husband's IQ score and the wife's IQ score. But does that mean high IQ score of the husband would actually causes the high IQ score of the wife, or high IQ score of the wife causes the high IQ score in husband? So causality represents the one variable causes the other variable, that kind of relationship. So it is not necessary, okay? Yeah, correlation does not necessarily will not give us the causality. So which one we should match this? What describes the relationship between two variables that one of the variables causes the other? Yeah, from the keyword we know this one should go to causality, right? Yeah, and this one would go to correlation. Let's see the definition of correlation. Correlation describes the relationship between two variables when the values of one variable are somehow associated with the other, yeah, the values of the other variable. That's a very good description about correlation. Yeah, very important, we need to know correlation does not mean causality. Yeah, exactly. Perfect. Thank you, Kylie. Next pair, precision and accuracy. When you watch the video, is optional meeting homework, right? Yeah. You might heard an example about the precision and accuracy. So I give one more pair definition to compare and contrast those two concepts. Sometimes the result of a research is very precise, but does that mean it is also accurate? Not necessarily, okay? Those two concepts are different. Yeah, which one goes to which one? This one says, describes the closeness of the measurement and the true value. Is precision describe that, or accuracy describes that? And this one says, refers to the amount of information that is conveyed by a number in terms of its digits. Yeah, those matching game not difficult, right? Yeah, accuracy perfect, awesome. Top is precision, exactly, awesome. Yeah, this is precision. Precision is means you have more detail. Yeah, in my example here, let's say pi. We all know pi is irrational, right? It is a non-repeating and non-terminating decimal irrational number. Yeah, there's many unlimited, like infinitely many digits to the right of the decimal point. We can only estimate, round it. We cannot know the exact value. And when we round it, we can round it as 3.1415926, or we can round it to 3.14. Yeah, they are both accurate. They are both accurate. Yeah, it's just rounding is different. But the first one has more information, right? Because it has more digits. So this one, 3.1415926, is more precise compared with 3.14. But they are both accurate. And accuracy describes the closeness of your measurement or estimate and the true value of the variable. Very good. So this is the first section. Any question about those basic concepts? I think the matching game should work for those concepts, especially they often just appear as a pair, right? Yeah. Any questions? I'm going to count 1, 2, 3. If no questions, then we're going to jump to the next section. Section 1.2. What do we do in section 1.2? We learn how to classify data. Okay, we learn how to classify data. Statistics is all about data. How do you design your research to collect data and organize data, analyze data, and interpret the result from the data. Yeah. Is the matching game available to us? It's in my OneNote. I think if you watch the video, you would have it. If you attend a class, and of course you don't have to watch the whole video again, right? The recording again, but you can jump and then see the page. I do not know how to upload my. What is it called? What is it? What is that? Chiral causality? Kelly? Do you mean do you have any question about the causality? Causality means a relationship between two variables that one variable causes the other. Yeah. And normally, how do we know one variable causes the other? If we can eliminate the existence of the underlying variable. For example, in an research, we study two variables. The first variable is the sale of ice cream. The other variable is the number of children drowning, like they swim and die. Yeah, and those two variables, since people collect the data and they find out they increase together. Yeah, when the sales of ice cream increases, the number of people drowning, children drowning, also increases. So they want to know is whether the sale of ice cream causes the drowning, or drowning causes the ice cream sale goes high. So actually neither. They do not have a causality relationship. In fact, there's an underlying variable is the temperature. When the temperature is high, people want to buy more ice cream, and more children want to go to swim, right? And more people, if they are not careful, they're gonna drown. If we can eliminate the existence of underlying variables, we can establish a hypothesis that one variable causes the other. So that's my understanding about causality. Did I answer your question? Yeah, it's better you can type the whole sentence. Okay, so section 2.2 about classified data. The first thing, the most general way to classify data is to divide the data into two parts or two types. The first type is a quantitative, and the second type is a qualitative. Very basic, the most basic division or classification of data. Quantitative versus qualitative. Quantitative is also called numerical. Yeah. Now, what kind of data is numerical or quantitative? Numbers, right? Not just numbers. And numbers represent counts or measurements. Okay? Yeah, for example, you are counting how many classes you take this semester. So we have this class. Yeah, you're going to do a survey. Yeah, how many classes you take this semester, you write down the number. And then you go to another student. How many classes you take this semester, you write down the number. So you are counting, right? So the data you got, they are counts or measurement. If you measure the temperature of today, and you got numbers, and those numbers are quantitative data as well, because they measure the temperature, right? And qualitative data is also called a categorical data. Those data do not measure or count. Yeah, since we only have two types of data, so if we understand what is quantitative, then we know all others, they are qualitative. So let's play the game now. Yeah, this one, first one, eye color, which one? Quantitative or qualitative? Is a category, right? Yeah, your eye color is blue, her eye color is brown, his eye color is hazel, something like that. Yeah, so qualitative for sure. What about this one? Which one uses units of measurement? Do we need to use a unit or measurement? Unit of measurement for eye color? No, this one goes to quantitative, right? Yeah, since looking at your chat takes time, I'll just finish and then look at it together. All right? Yeah. So of course, the quantitative data uses unit, and so important you have to point out the unit. For example, if you are collecting the speed of the vehicle passing you, if you stand somewhere by the highway, you're recording the speed passing you, of the vehicle passing you. You have to point out, is your speed in miles per hour or kilograms per hour, right? Of course, yeah, when you measure people's weight, you want to point out, is 120 pounds or 120 kilograms, right? Yeah, it's very important. So without those units of measurement, your data will not be meaningful, will be very misleading. This one, which one consists of numbers representing counts or measurements? Quantitative, right? Yeah, numbers that count or measurement or measures, those data are quantitative or numerical. This one, which one consists of names or labels? That's categorical or qualitative, right? Okay, gender. That's easy, right? Categorical for sure. And this one, age. Count, right? How many year old? Yeah, there's a unit. How many year old? Yeah, so that is a quantitative. This one, which one do not use units of measurement? Qualitative. Do not have to use units of measurement, right? Because it's not used to measure things. And this one, temperature. Temperature is a measurement, right? Yeah. Also, you have to point it out, specify Is the temperature, the number 70 is in Fahrenheit or Celsius, right? In Fahrenheit is a comfortable temperature, but in Celsius 70, you can boil an egg. It's different. Phone number. What about phone number? Which one? Yeah, quantitative or qualitative? We know phone numbers are numbers, right? Yeah, but which one should we go? Phone number. Like our campus police department phone number is 918-595-8888. Do we use that phone number to measure or count? Do we use that? Do we use the phone number to measure or count? Qualitative, awesome, thank you. Exactly. You guys great. Yeah. Qualitative, okay, is categorical, not quantitative. Yeah, exactly. Even it has a bunch of numbers, but it does not count or measure. So it is a qualitative. It is a categorical. Yeah, it's a kind of like a label. Yeah, it represents it connects to label my phone. Yeah, label my phone. What about this one? Which one? Yeah, this one says the number on the shirts of basketball players. Yeah, when you watch a sports game, yeah, basketball or baseball or football, the same. Those players has a shirt, and behind their shirt has the numbers, right? And then the host, the anchorman would say, number 11, do something, do something. So what about that? That data is a quantitative or qualitative. Is also qualitative. Exactly. You guys great. Even it's number, but it's basically the label. It represents the person's name. So now I see they just have name on the back. Sometimes I see that. So even this is number, but this number doesn't count or measure. So similar with the phone number, it is a categorical or qualitative. Last one, weight, quantitative, right? Yeah. And also you have to specify the unit. Yeah. 150 pounds or 150 kilograms. You have to really point it out. Okay, very good. I hope after this game you understand the difference between quantitative and qualitative. All right. Next. So for quantitative data, we can further divide those data, quantitative data, numerical, either count or measure, into two classification or into two classes. Yeah, into two types, two classes, discrete and continuous. So we can further divide quantitative data into discrete and continuous. Yeah, let's try to guess. This one says the number of values is finite. The number of values. So I would introduce random variable concept, the concept random variable. And we can use the random variable to represent the data you're collecting. Right? For example, I'm collecting the age of the students in my class. I use X, yeah, big capital X to represent the age of my students' age, yeah, in my class. So how many possible values for X? Yeah, how many possible values for X? I think probably finite number, right? Yeah, because especially when you guys are all pretty young. So this one should go to what? Discrete. When a variable only has a finite number possible values, then that is a discrete random variable. Discrete random variable. As you can see, the word discrete, there's a T separates two I's, right? Yes, separate. So it's like jumping. They are not continuous. Yeah, T separated two I's. So you either 18-year-old or 19-year-old. We don't really say like a 19-year and a 1 month old. So So you know I'm talking about, or 18 year and 13 days old. We don't really do that. Even you do that, it's still discrete because the possible values for the number for the variable is finite. Okay, is gender discrete or continuous? Let's think about if we see gender as a variable, how many possible values could we have for the variable? Yeah, nowadays we have probably more than just 2, right? Yeah, but anyway, it's gonna be finite number. So this one, and the number of value is infinite but countable. Very important. This one is also discrete. Okay. Let's give you an example here, actually. So if we consider an experiment, we have a fire die. We know die, right? Is a cube. Is a cube, and 6 sides. On each side, we have a number. We have a certain number of dots. Number 1, number 2, 3, 4, 5, 6. So let's play a game. We roll the die, and we count the number of times you have to roll the die before you see the first 6. Before you see the first number 6. If you get lucky, then you got number 6 right away the first time, right? So the variable there's only 1, so you only need to take 1 count, 1 time. Maybe the other person needed twice, the second time you get a number 6, right? Yeah, is that possible? You keep rolling the die, and you never get a number 6, and continue. Theoretically, yes. Okay, this can be the example to explain this option. If the variable has infinitely many possible values, but those infinitely many possible values are countable. What is countable? Means we are able to count it, even if it takes forever, but we are able to count the number 1, 2, 3, 4, 5, 6, and so on and so on. Okay, and that is different from infinite but uncountable. Irrational number, you know what? Rational number is countable. Irrational is not. That makes the whole real number set uncountable. Imagine temperature. Okay, imagine temperature. You are measure the temperature of today, right? You have a minimum, like lowest temperature and a highest temperature. That gives you an interval, right? That gives you an interval. Yeah, from 65 Fahrenheit to 90 Fahrenheit. When the temperature changes, would it jump like from 70 degrees suddenly to 71 degrees? It doesn't jump, right? It doesn't jump that way. It changes gradually, continuously, going through all the real numbers from 70 to 71. So temperature is a continuous data. Because if we see temperature as a variable, yeah, the variable represents today's temperature in Tulsa, then the possible values of the variable could be infinitely many and uncountably many. Yeah, those values would fill in a certain interval on the real number line. Yeah, what about age? Age is discrete, right? As I said, even you count the days is still discrete. You will not, even you count a second, is still discrete. And what about weight? Weight is continuous, right? Because if you gain some weight, or if you want to lose some weight, you want to lose 15 pounds, would you suddenly lose the 15 pounds? It's not possible, right? It's gradually. So the variable of the weight is changing gradually. It goes through all the real numbers at a certain interval. So that is continuous. And let me know, am I clear about the difference between discrete and continuous? My understanding is Discrete data counts. Continuous data measures. Yeah, most of time. All right. Yeah, let me see any questions from here. Okay, very good. Then we move to the next one. Another way to classify data is to use the 4 levels of measurement. 4 levels of measurement. When you do a homework in 1.2, you're going to see tons of the problems is about the 4 levels of measurement. Yeah, we are going to look at this table to understand the 4 levels of measurement. Which 4 levels? Ratio, interval, ordinal, and nominal. I'm going to start from ordinal and nominal. Okay? Yeah, ORDINAL, especially the first 3 letters, ORD. Same with order. Same with order. So data that has a certain order, the data that you are able to arrange them in order, those data is ordinal. Data that can be arranged in order, but differences either cannot be found or are meaningless. We do not take the difference between the data that you arranged in order. Those data are ordinal, satisfy the level of ordinal. For example, ranks of colleges in U.S. News and World Report. Those ranks are ordinal, right? Yeah, top 10, there's an order. But does that make any sense if you use the first top 1 university to minus the second place university? That probably doesn't make any sense, right? It does not make any sense or cannot be found. And other examples about ordinal is our letter grade. By the end of the semester, you will receive one of the following, either A or B or C or D or F. Do they have an order? They do have an order, right? A is the best, of course. And nobody want to have F. So, but the difference, if you use the letter A to minus letter B, I don't see much meaningful thing in doing that. So the letter grade in a class, that kind of data satisfy ordinal level of measurement. Anyone can give examples about ordinal? Hello? Anyone can give examples about ordinal? What kind of data satisfy ordinal level of measurement?
Do you mean like if a school has a high rank, like ORU has the best soccer players versus OSU, like that?
That's a good one. That's a good one. Yeah. If you have the data that they can arrange in order, like you said, a certain sport, right? Yeah. As far as maybe a basketball concern, the team concern, yeah, OSU is the first, and maybe another university the second. Yeah, that's good. That's good example about ordinal. Yeah, you are able to arrange them in order, but the difference does not make sense. Yeah, let's see any other answers. Placement in computation. Yeah, that's good. That's also good. And this one is test scores from a test in college. Test scores. I think test scores is not ordinal. Test scores is a ratio. For example, one student, let's say 100 points is the maximum. One student get 50, the other student get 100. So the ratio 100 over 50 is twice. You see someone scores twice of the other student's score. That makes sense. That is meaningful. So it is not ordinal. It is a ratio. Yeah. How do we know the difference between ratio and ordinal? The ratio normally refers to numerical most of the time, and ordinal is more like a categorical, qualitative. Does that make sense? Would a pen? Yeah, that's a good one. Perfect. Yeah, thank you, Melinda. Pen scale is a good example about ordinal, or the tolerance about the pen, right? People have different tolerance about the pain, or the stress level, right? Yeah, many of those things. Or when a company survey your opinion about the product, you write good, okay, bad, right? Yeah, good of course is better. You very intuitively you can order them. Good is the best, and then okay, a little bit less, and then bad is really bad. Is the worst, right? How is a pain scale not ratio when there is a starting point of 0? That's a good question. What is a pain scale? Is numerical. Give me 1 second. Let's see how does the pain scale work, okay? That's a very good question. Yeah, why is it not ratio?
I think there's differences though.
involves-
There are pain scales that uses numbers, and there's pain scales that uses like facial expressions.
Yeah, like I feel I'm very sensitive to pain. I'm neutral to pain, or I'm numb to pain. In that case, definitely is ordinal, right? You see what I'm talking about? Yeah, it really depends on the more details, the specs about the pain scale. But that's a very good question. Very good question. Normally, the problem you encounter would give you enough detail for you to decide. Well, not just the pain scale. They will give you more detail about that. Yeah, more sensitive. Yeah, you often get a survey. I agree strongly, or I agree, absolutely agree, and I agree, or neutral. I strongly disagree. Those are ordinal as well, right? Those are ordinal as well. Good question. I like the discussion. And how about let's move to nominal? Yeah, nominal is pretty easier compared with others to decide. Yeah, nominal level of measurement refer to data that they are categorical. Yeah, only represent the categories, and they cannot be arranged in order. For example, eye colors. How do you arrange eye color in order? No, it's just different categories, right? Yeah. Any examples about nominal? Yeah, brainstorm. Any examples about nominal? Represents different categories but cannot be arranged in order. Eye color. Yeah, when I every time they fill out some information, are you white? Are you Asian? I think those could be nominal. Those definitely is nominal, right? You cannot arrange them in order. Otherwise, it's racist. So quiet. Okay. Let's see. Religion. Religion is a good one. Let's stay away from races. Body parts. Yeah, exactly. If you are nursing major, we have so many different names for the muscles, bones, nerves. Yeah, those are just the categories, right? Yeah, very good, very good, perfect. And so ordinal and nominal, we're done with that. And the other two, ratio and interval, those two are the two people get confused most easily. Let's read the definition. Ratio, what kind of data satisfy the ratio level measurement? Yeah, ratio level measurement has A true zero, has a natural starting point, and ratios make sense. For example, height, like your height is twice of your son's height, or triple your son's height, right? And there's a zero starting point for the height. If the height is zero, that means there's no height, right? Or length or distance, similar with height. Or volume, this can, or capacity. This can is twice capacity of the other can. So it can contain twice content compared with the other can. So ratio makes sense. That's the reason the name of the level of measurement is ratio, right? Very important thing we need to remember, ratio has a true zero, When the volume is zero, that means there's no capacity, right? Yeah, when the distance is zero, that means you didn't move, right? Okay, so interval instead does not have a true zero. It doesn't exist. For example, body temperature. People might say, why not 0 degree, right? Yeah, 0 degree in Fahrenheit or in Celsius. If 0 degree in Fahrenheit, that means the body is frozen. If 0 degree in Celsius, it's still frozen. I mean, in the edge, it's still cold. Yeah. Either way, those zeros in 0 degree in Fahrenheit or Celsius, that is mandate. That is people come up with the zero. That's not true zero. Even when the body temperature is zero, either in Celsius or Fahrenheit, it has a temperature there. The temperature exists. Do you see what I'm talking about? Even the body temperature is 0 degree, but the temperature, the 0 degree exists, is there. It has a temperature. And also the time in year. So another thing about interval is the ratio are meaningless. Can we say, anybody know where does the time start from? Yeah, now we are 2023, but that is people made it up, right? People, for convenience, they come up with the calendar, but it's just a way to serve the society that we can, function following a calendar. But what's the starting point, natural starting point of time? I do not know. So it does not have a natural starting point, and that kind of data satisfy the interval level of measurement. Okay, does that make sense? The reason that the ratio does not make sense for interval is because it does not have a true zero. When the data has a true zero, of course you can take a ratio, right? You can take a ratio. But we can do the difference. We can subtract for the interval. Yeah, your temperature go up 1 degree, and the difference is 1 degree. Or this year compared with 10 years ago, the difference makes sense for interval. So interval kind of go to horizontal, right? Yeah, horizontal operation makes sense. That might be something you can remember. You can connect with the name that help you to remember the definition. Am I clear about the ratio and the interval? And maybe we can practice now, yeah, to see if you remember that. The first one, age. Is age ratio, interval, ordinal, or nominal? Do we have a true zero for age? Yeah, either you count pregnant. I'm sorry. Either you count the birth, the moment the baby is born. I think yeah, either you count the moment the baby is born as 0, or you count when the baby form in uterus, right? So it has a natural starting point. So yeah, it is ratio. Awesome, very good, perfect. This one is an example of what? Yes, no, and yes or no or undecided. Are they in order? Or the order doesn't make sense? This is a qualitative, categorical. Let's see. That's nominal, perfect, exactly, category, yeah. Yes, no, undecided, perfect. What about this? Years. We mentioned that earlier, right? Yeah, this one, it does not have a true zero. So can only subtract, make a difference horizontally, cannot take a vertical ratio. So it's an interval. Interval, awesome, very good. You guys are great. And this one, social security numbers. Social security numbers. Yeah. Let's see. I don't think it's the interval for sure. It does not have a true zero. Nominal. I don't think you can order. I would say nominal. Yeah, that's the order of the. I have to ask them. Ask who? Maybe the Social Security Department. Maybe they don't know either. I would say nominal is just the labels, like eye color. It represents you. It's like your name, right? Yeah, your social security number represents your identity. I would say is nominal, not ordinal. Do you guys agree? Not ordinal. I don't think you can order them. No, I don't think you can order them. Okay, yeah, it is nominal. This one, the difficulty of the problem, when I added to your homework, I have to look at, is this problem easy or medium or high, right? Yeah, what about that? This is ordinal for sure, right? Yeah, when you go to a Thai restaurant, you want to order some spicy food, and they would ask you, you want a mild spice, for the spicy food, you want a mild or medium or hot or super hot, right? They always ask you that. Yeah, so that is ordinal for sure. Perfect. And this one, which one has a true zero? Interval has a true zero. Yeah. Which one does not have a true zero? Ratio does not have a true zero. Oops. It's moving. Yeah, ratio does not have a true zero. We went over that. What about volume? Volume is ratio, right? Yeah, twice bigger capacity-wise. What about
I'm sorry, I'm sorry to interrupt, but I thought ratio has a natural zero where interval has no natural zero.
Oh, hold on. Oh yeah, I put it wrong. You're right. Yeah. Interval does not have a true zero. So we cannot take a ratio. I'm sorry, I apologize. Yeah. And ratio has a true zero. Yeah, like age or volume. My bad. Thank you for pointing out. Volume is ratio, right? It has a true zero. Yeah, no capacity. When volume is zero, then you cannot put anything in the space. And what about class time? Some of my class, 1 hour, 20 minutes. Some of my class, 1 hour. So I have one class, 12 week. It is 1 hour and 45 minutes. In other school, I teach some classes me 3 times a week. That's only 50 minutes. So class time is what? Does it have a true zero or not? Class time. Not the time in years or in calendar years. It's a ratio, right? It's a ratio. If something happened and the class only lasts like 30 minutes, and when it's supposed to be 1 hour, then the class time is like twice of the half of the regular time, where the regular time is half of the time when is shortened because of an accident. Class time is a ratio, okay? It has a true zero. If we cancel the class, 0 minutes, right? Does that make sense? Do you agree?
That makes sense. We agree. I think we were looking at it from like, oh, like it could be a 50-minute class or an hour and 30-minute, and it could. So the class times are somewhat arbitrary. So I think that's where I thought interval.
It's a ratio, right? It has a true zero.
Oh yeah. When
we cancel a class,
the time for
0
this
minutes.
class has a true zero at 7:30. Yes.
I mean, if we cancel the class, it's 0 minutes, right? It has a true zero. Yeah, the reason I put this here, because some people confuse this one with the years, because we just agree time in years is the interval, no true zero, right? And this is also has a time in it, but this time refers to a period of time, is a measurement. A period of time, the time length of a class. So it does have a true zero. It does have a true zero. So it is a ratio, right? But class start times would be start time. Let me think. Start at 7:30. Or start from 6. Yeah, I think what you said makes sense. If you have 3 different classes that start at different times, yeah, I believe so. It's like your time, the time is at certain point on your calendar, right? On your calendar. So the time on your calendar. If you are referring to class times, it is ratio. Yeah, I agree. If you only talk about the starting time, yeah, it's interval. I agree with the interval. Because like the same with year in calendar. Or you are saying time, a specific time in calendar. So anything on the calendar is the interval, because the calendar doesn't have a natural starting point. We don't know when does the time start, right? Good thing, yeah, good discussion. I really like that. And let's see, we'll have one more. Letter grade. Yeah, we mentioned this earlier. Ordinal or nominal? Oops, I think I messed up the thing. Where it goes? Where's my letter grade is ordinal, okay? Yeah, we mentioned that is ordinal. Perfect. Awesome. Yeah, I'm gonna fix that later. Okay, so that's second section, classifying data. So now we're going to move to the next section. Yeah, exactly. Collecting data. How do we collecting data? We have to consider the source of data, right? We have to consider source of data. We have 2 main sources of data. The first one is observational study. Yeah, think about the name, observational study. The second one is experiment, or experiments in plural. Okay, let's give it a guess. Okay, here, try those 2 first. Which one do you think has a certain or some treatment applied? Yeah, which one does not have any treatment applied? Yeah, think about the name. Yeah, just a guess. Experiment, no treatment, right? Yeah, sorry. Observational, no treatment. Yeah, if you think about the name observational study, you just observe, right? Yeah, no treatment, exactly. That's the main difference of the 2 sources of data. Yeah, so if you collect your data from through observational studies, and you do not apply any treatment. If you collect your data through experiments, yes, you would have to apply certain treatment. So that's the main difference between the two sources of data. And this one goes to observational study. Okay, yeah. So if you are doing a observational study, you have three ways to do that. If you collect data in a time point, in a point of the timeline, yeah, like at this moment, I'm collecting your feeling. Yeah, on Facebook, is pretty interesting. On Facebook, there's a what are you feeling at this moment, right? So if you collect the data at a certain moment, one point of the time, then that is called cross-sectional study. Yeah, this is about the observational study. Okay, you do not apply any treatment. You only observe and collect the data. And also, you can collect the data from the past. If your observational study is done from the past, it's called a retrospective study. And the word, the prefix, yeah, retro means look back, right? Yeah, yeah, retrospective study. That is another type of observational study. Means you observe and collect the data from the past. Or sometimes we want to collect data in the future, from the future. Yeah, that is called a prospective study or longitudinal or cohort study. I remember the first time I heard about this kind of study from the documentary. Yeah, it was very impressive. I was very impressed. It's the London some university. They do the research. They follow up with a few babies, right? Yeah, they were born at the same time, and every 7 years they interview them to see what's going on in their lives. Every 7 years, every 7 years, every 7 years. So that kind of research, observation, yeah, assume they only observe and interview. They do not interrupt or interfere their lives. Okay, yeah, that is observational, and that is a prospective data, a study, because the data is collected from the future. Yeah, all those three types of studies, they are observational study. In fact, this is the classification of observational study. You just know we have three different types of observational study. Depends on your purpose, the purpose of your research. You can try one of the three. And let's see what this one. Which one has the gold standard apply? What is the gold standard? Yeah, let me show you. This is the gold standard. What is the gold standard? Randomization with placebo treatment groups. Yeah, you see the keyword treatment, right? And you know that's gonna be experiment. Yeah, if you randomly, for example, yeah, that gold standard is very good. Yeah, experiment, perfect. Yeah, experiment. You follow the gold standard to design an experiment. Very likely is a good research. It's good design. What is the randomization with the placebo and treatment? Let's say you want to test a new medicine, right? Yeah, you randomly select. You do not just select on purpose a certain type of patient. You randomly select the patient, they have the problem, right? The medical issue. You randomly select those patients and make a sample. And then you randomly divide them into two groups. Yeah, maybe you flip a coin, right? Okay, you flip a coin. If you get a head, you go to the first group. If you flip the coin, you get a tail, you go to another group. Yeah, that is one way of applying randomization. And then you give one group placebo, and it's better doing that by applying blinding, means they do not know what kind of thing they are receiving, a medicine or placebo. Then we can get around a placebo effect. And the other group you give treatment, and over time you test the result to see if any difference, significant difference. Experiment, okay, replication. Yeah, exactly. Yeah, that one also is talking about experiment. A good experiment has to be repeatable. Yeah, you can do the research. Other researcher, they should be able to repeat it and get a similar result. Observational study also repeatable, but they don't have blinding, and they do not have blinding. So the best way to design an experiment is to apply double blinding. Double blinding means when the patient do not know, or the subjects do not know, are they receiving placebo or are they receiving medicine, real medicine. Also, the people, the provider who give the placebo, who distribute the placebo and the medicine to those patients, they do not know either. They use code. The researcher know. The researcher are the only people who know by code. This way, that the provider will not have any way like a body language or gesture will like give the hint to the patient. So it's better to apply double blinding. And randomization, yeah, we would talk about randomization earlier. Which one sensitive to lurking variables? Yeah, the lurking variable is the underlying variable that I mentioned earlier in an example. Yeah, variable X represented the sale of ice cream. Variable Y represents the number of children who drowned, right? Swimming. And I earlier used that example to explain even they do display a certain correlation, but there isn't any causality between the two variables. The reason is because there's a lurking variable. What is a lurking variable? Lurking variable is a variable that affects the variables in your study, but is not in your study. Yeah, the lurking variable is not in your study, but it affects your variables. It affects the variables in your study. So which one is sensitive? Which one is sensitive to lurking variables? This one. Experiment is better because you have more in control, right? You can control it better. Experiment observational, yeah, is more sensitive to lurking. Yeah, exactly. Yeah, I earlier said experiment is a better source of data compared with observational. Then why don't we just do experiment? Because many times we cannot do experiment. It's unethical. For example, you want to know if smoking really causes cancer, lung cancer. Then how do you do experiment? You ask people to smoke, and then to see if they get a cancer. That's not good, right? Yeah. Or driving and texting, you ask the people to drive and texting to see if you die in a car accident. That's unethical. So many situations, even experiment is a better way to collecting data. It is limited by many ethical issue and other issue. So you would have to do observational study. Even observational studies are sensitive to lurking variables. And which one only observe or measure? This one, right? Yeah. No treatment. Okay, next topic. Yeah, we're gonna hurry up. Sampling method. So getting a sample from population is so essential to our statistical research. If your sample is good or bad, directly affect if your result is valid or not valid. Okay, yeah. So we have more than that, but we only introduce the following sampling methods: systematic, convenience, stratified, cluster, random, and simple random. Okay, yeah, that's going to be the last topic. We have 5 minutes. Yeah, which one is systematic? This one is systematic. Let's say you want to do some survey about the people's opinion about a certain product. So you stand outside the mall, yeah, by the gate of the mall, and you're gonna pick the every third people that you see. Every third people you see, you ask them a question and record a response. Every third, right? And that is a systematic sampling method. Yeah, normally we need a, excuse me, normally we need to select a starting point, and every case subject, we select every case subject and form a sample. In a factory, let's say the factory, the enzyme line producing cookies, and quality control people, quality control staff, you know, when it's closer to the class, I'm going to take another picture of the attendance and then compare the one I had earlier. Let's get it quickly. Yeah, so the quality control staff probably would adopt this method to get a sample. Yeah, every 100th cookie, right? Yeah, assume produce a lot of cookies. Every 100th cookie, yeah, every 100 cookie, and you get a sample and you test the quality. All right. The next one, convenience sampling method. Which one should we match? Yeah, which one sounds right? Yeah, this one. Yeah, which is easy, right? For example, I want to take a sample from our class. I go to my roster. I only choose the one initial is A for the first name. Initial is A. That is a lazy way, right? It's convenient. Yeah, the reason I do that because it's easy to get. Yeah, that is a convenience. Very likely convenience sampling. Very likely convenience sampling method results in a biased sample. And stratified and cluster. Okay. I'm gonna match them quickly. Okay. Yeah. And you can please read this one and yeah, this one and this one. Yeah, there's a keyword here, so you will not get confused. Yeah, this one has a keyword strata. It corresponds to stratified, and this one has a keyword cluster, so it corresponds to cluster sampling method. Let me give you 2 examples. Okay, so let's say you go to a university, 4-year bachelor university. You want to get a sample, let's say size 1,000. So you divide all the students, let's say only full-time students, into 4 subgroups. Yeah, 4 groups: freshman, sophomore, junior, and senior. And then from each group, I randomly select a sample. So I have four samples, right? And then I combine the 4 samples, I got a sample. That is a stratified sample. That is a stratified sample. Stratified sampling method is to divide population into groups. And from each group, every single group, you draw some members. You draw a sample. So that is stratified. And cluster, those two are very similar. Cluster also involves dividing the population into groups, and we call that clusters. Instead of picking randomly selecting a sample from each group, cluster sampling method is to randomly select some of the clusters. And then from the clusters, we choose all the members. For example, I go to the university, the same university. I want to get a sample of 1,000 students. I divide all the full-time students into 4 categories or 4 classes. Freshman, sophomore, junior, and senior. And then I randomly select 2 clusters. Randomly select, for example, junior and senior. And then I take all the members from those 2 clusters. That method gives us a cluster sample. Do you see the difference between stratified and a cluster? It's different, right? Yes? Okay, the last 2, random and simple random sample, I'm going to explain that next time when I see you. Okay, I'm going to explain that maybe a few minutes on Tuesday, and then we go ahead to start chapter 2. Any question about today's content?
No, I don't have a question about today's content, but I went on and did the very first quiz for like 1.1, and it did lock me out after my 3rd try on on the very first problem. So it only allowed me 3 chances to get it right, and I thought it was unlimited for the quizzes.
Are you talking about 1.1 assignment?
Yes, sorry, the assignment. Thank you.
Assignment, okay. Assignment should have unlimited.
Yes.
I'll double check and let you know. What's your name?
Callie Burgess. So it's question 1 on 1.1.
If you hit similar problem and solve it correctly, it'll give you the points back.
Okay. Okay.
Oh, she answered your question. Now I understand your question. She answered you. Yeah, you would have a similar question.
Okay.
Yeah, not
that
exactly.
Sounds great. Thank you.
No problem. Where can we review the class recordings? That's a good question. Did you receive my email? Tuesday 9 and the first shorts. Yeah? Did you receive my email? The first short. Kayla. My email? Tuesday 9.
Tuesday 9.
And the first short. The reason I cannot show you right now because we are using the virtual classroom. It will not let me to demonstrate it here. How about you find the email and click the link and watch the short.
Okay, thank you.
No problem. It's called Navigate Virtual Classroom.
Okay, thank you.
Yeah, no problem. Any other questions? Okay, so I appreciate your time tonight, and I will let you guys rest, and I'll see you on Tuesday. If you have any questions, please feel free to email me. Okay? Yeah, thank you for coming. You guys have a good night. Really late now. See ya. Bye-bye.